Welcome, my name is Dr. DrWedding, and this is DrWedding DC03. Reading resistor codes and variable resistors. This video will cover how to read the color code on a 4-band resistor, a 5-band resistor, as well as the numeric code on a surface mount resistor. As you learn about circuits, you will eventually move away from calculations on paper and start to build and test circuits in the lab. This requires you to read and identify the components. This will also reinforce the use of metric notation that was covered in the last video. This video will also introduce a few different types of variable resistors and how they differ from fixed resistors. The first part of this video will explain how to read the color code of a through-hole part. These types of resistors have 2 metal leads on them that are put in holes on the printed circuit board. These types of resistors are also used in labs because they can be plugged into a test board. In the real world, many resistors are surface mount, called surface mount devices. These resistors do not have a color code, but a numeric code. If you work with industrial electronics, you will need to know how to read these types of resistors. There are 2 main types of color-coded resistors, a 4-band resistor and a 5-band resistor. Let's start with a 4-band resistor. In a 4-band resistor, the first 3 bands indicate the nominal value of the resistor. The 4th band indicates the tolerance. Each color corresponds to a number. Therefore, if you need to read a resistor, you just need to know what number each color represents. Each number is represented by a color. This color code needs to be memorized so you can read the resistor's value and tolerance. To help you memorize the color code, a sentence is listed next to the code. Each word in the sentence has the same starting letter as the color it represents. To use this memory trick, start by memorizing the sentence, "Big boys race our young girls, but violet generally wins." Sometimes people add gold and silver to the end. If you need to know the number associated with a color, you start to say the sentence slowly. When you say big, you should make a fist because the first value represents 0. Every time you say a word in the sentence after big, you need to raise a finger. For example, assume you need to know what number green represents. First you say big and make a fist. Next you would say boys and raise your first finger. Next you would say race and raise your second finger. When you say our, you would raise your third finger. When you say young, you raise your 4th finger. Finally, when you say girls, you raise your thumb. Girls represents green, so you stop. You can see you have 5 fingers raised, so green is equal to 5. So the nominal value of this resistor is 102. But what does that mean? The first number is the first digit of the resistor. The second number is the second digit of the resistor. And the third color is the multiplier. Think of this as how many zeros you add after the first 2 digits. So the nominal value is 1, 0, 0, 0. So this is a 1000 ohm resistor. The ohm is the unit of electrical resistance and is represented by an omega. The tolerance is not as easy to memorize, but by looking at the chart, you can see that gold is a 5% tolerance. The nominal value is the value that the resistor would be if it was perfect. But these types of resistors are not often perfect. That is why there is a tolerance band. The tolerance band is how much over and how much under the nominal value the resistor can be, and still be within tolerance. The gold band means that this resistor can be 5% over and 5% under 1000 ohms, and still be considered a 1000 ohm resistor. The easiest way to understand the tolerance band is to think of it as money. A 1% tolerance is like a cent. A 5% tolerance is like a nickel. And a 10% tolerance is like a dime. The tolerance is how much you will add to a dollar to calculate the maximum value. The tolerance is also how much you will subtract from a dollar to calculate the minimum value. This resistor has a gold band that represents a 5% tolerance. So you can get the maximum value by multiplying the nominal value by 1.05. Think of this like $1.05. And to get the minimum value, you multiply the nominal value by 0.95. Think of this like 95 cents. If this was a 10% resistor, you would need to multiply by 1.10 to get the maximum value. And you would multiply by 0.90 to get the minimum value. Most of the time, components on a schematic are written in metric notation. So when talking with your coworker, they may say it is a 1,000 ohm resistor, or they may say it is a 1K ohm resistor, or they might just say it is a 1K and not say ohm at all. Based on the circumstances, the resistor might even be referenced as a 0.001 megaohm resistor. Calling the resistor by any of these names is all equally correct. This is why it is important to understand the metric notation that was covered in the previous video. This page has 5 resistor color codes on it. You can pause the video and see if you can get the nominal value, maximum value, and minimum value for each resistor. Once you are done, you can restart the video and check your answers. Here are the answers. Keep in mind that these values can be in different metric forms. So even if you do not have the exact same answer as shown here, you still might have an equivalent answer that is also correct. In the description below, there is a link to a free program on my webpage. This program will let you change the colors of the resistor, and it will calculate the nominal, maximum, and minimum values. 4-band resistors are not the only type of resistor. There are also 5-band resistors. These resistors are often a teal green, sea foam green, or light blue color. The color code for a 4 and 5-band resistor are the same. The only difference is the nominal value has a first, second, and now a third digit. The fourth value is now the multiplier, and the fifth value is the tolerance value. Just like the 4-band resistor example, this 5-band resistor is a 1K ohm resistor. In the 4-band resistor, the value bands used to calculate the nominal value were brown, black, red. In the 5-band resistor, the value bands used to calculate the nominal value are brown, black, black, brown. The first 3 bands are brown, black, black, representing 100. The brown band in the 4th position lets you know that you need to add one more 0 to make 1000. The maximum and minimum values are calculated the same way for a 4-band resistor and a 5-band resistor. This 5-band resistor is 1000 ohms and has a 5% tolerance. So the maximum and minimum values are the same as the previous example. This page has 5 resistor color codes on it. You can pause the video and see if you can get the nominal value, maximum value, and minimum value for each resistor. Once you are done, you can restart the video and check your answers. Surface mount resistors are very small flat ceramic rectangles with metal deposited on both sides. They can be put on a circuit board with a pick-and-place machine, and they can be soldered to the board with a wave soldering machine. And because they are so small, they are ideal for use in handheld devices like a remote control, a key fob, or a cell phone. All of these characteristics are great when it comes to mass production, but these same characteristics make them difficult to use in a lab. Even though you won't use this type of resistor in a lab, you will use it in industry, and you will need to be able to read the resistor code. The surface mount resistor code is the easiest code to learn for 2 main reasons. First, there is no tolerance marked on the resistor, so you only need to calculate the nominal value. Second, there is no color code, just numbers, and the numbers are read the same way as a 4-band resistor. This resistor is marked 102. So the first digit is 1, the second digit is 0, and the third digit is 2, meaning add 2 more zeros to the number. That makes this resistor 1000 ohms. This is the same way you would read the first 3 colors on a 4-band resistor. You just get to skip over the color code and go straight to the values. This page has 10 surface mount resistor numeric codes on it. You can pause the video and see if you can get the nominal value for each resistor. Once you are done, you can restart the video and check your answers. Here are the answers. Keep in mind that these values can be in different metric forms. So even if you do not have the exact same answer as shown here, you still might have an equivalent answer that is also correct. In this video, you have learned how to read the values of 3 different fixed resistors: the 4-band resistor, the 5-band resistor, and the surface mount resistor. Learning how to read these values was the main focus of this video. The next part of the video is an introduction to the variable resistor. A fixed resistor never changes. These resistors are essentially the same from the day they are manufactured to the day they are destroyed. These are the resistor types that will be primarily used in this course. However, there are a lot more resistor types than just fixed-value resistors. Some resistors change depending on their environment. These are called variable resistors. This section will give you a quick overview of variable resistors that are used in later courses and in industry. A potentiometer, also called a pot, has 3 pins. The outside pins are A and C, and the resistance between these pins is a fixed value, and it is marked on the pot. A knob in the middle of the pot moves a wiper arm that is attached to the middle pin, marked B. The wiper will electrically cut the resistor into 2 smaller resistors. The resistance from A to B, plus the resistance from B to C, is always the fixed resistance from A to C. For example, if the knob on a 10,000 ohm pot is moved so the resistance from A to B is 1,700 ohms, then the resistance from B to C must be 8,300 ohms. Because resistors only come in certain values, a pot can be used to create a non-standard value using the middle pin and one of the outside pins. A thermistor is a resistor that changes with temperature. The value marked on the thermistor is the resistance of the device at 77 degrees Fahrenheit, which is the same as 25 degrees Celsius. There are 2 types of thermistors. The first type is a positive thermal coefficient thermistor, and as the temperature increases, the resistance increases. The second type of thermistor is a negative thermal coefficient thermistor, and as the temperature increases, the resistance will decrease. A thermistor can be used with a more complex circuit to monitor the temperature of a device, such as the temperature of the CPU in your computer or the air temperature in your home. A photoresistor, also called a photocell, is a resistor that changes its resistance with light. A photoresistor works just like a thermistor, but it reacts to light instead of heat. Just like a thermistor, there are both positive light coefficient and negative light coefficient versions. Photoresistors are often used to turn on lights when it gets dark and turn them off when it gets brighter. The last variable resistor discussed here is the force-sensitive resistor. As the name suggests, the resistance of this resistor will change when there is pressure applied to it. This type of resistor can be used under a mat to actuate an automatic door, or it can be used to monitor the weight of an object that is resting on it. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.